the sun is not behind the moon during a solar eclipse. And then I ran away. What? What are you talking about? The confusion, right? So what are we doing here? Well, we've come to talk about where the sun is during solar eclipse, during that moment when people are right in front of the, oh, that's cool actually, you could see that light, see the corona of the bulb. That moment, that magical moment when people are in the eclipse sweet spot. Florida, right? They're in the sweet spot. But if the sun's light has taken 8 minutes and 20 seconds to reach this pair, actually it's 1 second, 1.3 seconds sooner here, okay? And then it takes another 1.3 seconds to come aft here, okay? Shit. Sorry. Right, so where on earth would the sun be? It cannot be there, can it? If it takes 8 minutes and 20 seconds to do this trip, how can it be there? How can it be there when people are looking at the straight line between their eye, the center of the moon, and the center of the sun? If it's taken 8 minutes and 20 seconds, what's out here? There's something wrong. 4.6 seconds per sun diameter, remember? 108 sun diameters in between the sun and earth. 4.6 seconds multiplied by 108. That is 8 minutes and 20 seconds for that light to reach this pair. Push. Gonna have to get that seen to. So what are we gonna do? Where is the sun when this is happening? The thing is with this, it's obvious you don't understand your science because the comments, right? The comments, all of them are just bullshit. We need to know what's happened in this 8 minutes and 20 seconds. What we do know is the sun may as well be a statue. It's static, not moving. It is moving, allegedly, but for us, it's not. It's so far away, it's just there. We spin on our axis. That's what creates day and night. It is not the sun shifting. It's us moving on our axis. Knowing that, what do we do? 8 minutes and 20 seconds, fair enough. But what we really want to know is how far do we move on our axis in 8 minutes and 20 seconds? That will tell us a bit more about what's going on. How do we do that? Let me just make sure I'm zoomed in. Oh, I don't know how much you may have missed. I was pretty close to the action, I think, there, so I'll let that go. Right. What kind of a distance we spin? 360 degrees in 24 hours, right? Now we want to know how many degrees we spin in 8 minutes and 20 seconds. So how do we go about doing that? The easiest way, I think, so we're going to turn this 8 minutes and 20 seconds into 500 seconds, all right? That is how long it takes for the sun to radiate its light to planet Earth. 500 seconds, 8 minutes and 20 seconds. Alexa, how many seconds are there in 24 hours?
24 hours is 86,400 seconds.
86,400 seconds in 24 hours. We've got 500, so we want to know 24 hours, that's 360 degrees, right, in 24 hours. We divide it by 500 because that is the little time slot that we want. We want to find out how many of them are in there. Alexa, what's 86,400 divided by 500?
86,400 divided by 500 is 172.8.
There are 172.8 500-second slots in 24 hours in 86,400 seconds, right? So now we've got that, we want to find out what kind of a slot that is in degrees. So we divide the amount of degrees there are in one revolution. Alexa, what's 360 divided by 172.8?
360 divided by 172.8 is approximately 2.0833.
And that is degrees. We'll call it 2, if that's all right with people. I won't say it's perfectly just close enough that we can call it 2 degrees and not get into trouble. Right. Oh, the battery's going. Florida. The moon is bang over Florida. Everybody in Florida has just come over and they are hoo-ha. Beautiful. The moon, bang, big. The sun behind it. See the sun's corona. It's bang on. But 8 minutes and 20 seconds. So what does that mean? What that means is the sun that is now hitting the moon and impressing everybody in Florida actually left the sun when planet Earth was 2 degrees further that way. So when the sun was shining on the moon, when it was over the Bahamas, that kind of a thing, right? And Atlanta, it's just coming towards Florida's east coast, and it goes boop, 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 bang. 8 minutes and 20 seconds later, Florida is looking through the moon and at an 8 minute and 20 second old sun. That is what is happening. So, because Florida is bang on looking at the moon, thinking it's a beautiful full eclipse of the sun, it is, but it's not, because the light that you're seeing, that they're seeing, it's 8 minutes and 20 seconds old. It actually left the sun when planet Earth was, you were facing that way. You knew it was coming, so that sun, you've moved, ding, and it's 8 minutes and 20 seconds old, I'm afraid. So there can never be a live eclipse, right? There can never be a live eclipse of the sun, unfortunately, for y'all. It's live for me every time. I've seen a few around the world, and it's always awesome. And I always have the common sense to know that it's absolute light. The sun is there radiant absolute light like a laser beam, because you know everybody's like that, and it's covered up for that minute or 2 minutes, and then as soon as the sun comes out, there's a ping. It's like far out. Oh, God, that caught me off guard. 8 minutes and 20 seconds. Don't be ridiculous. So that is your science. That is your 8 minutes and 20 seconds broken down. So from now on, you can say it takes the sun 2.08 degrees of our axis spin to reach us, right? As soon as the sun leaves the sun towards us, we will spin on our axis by 2.08 degrees before it can reach us. How about that for a new absurdity? Because it's true. And the thing is, it's so ridiculous, right? It's so ridiculous. The things that they say with this finite light to be measured. Light travels without a source, they say. Without ketchup, without mustard, without source. No, look, if there is not a source, there is no light. So the next part is yet another absurdity. Right, what we have, oh look, that bloody battery's going to go, battery's going to go, battery's nothing I can do, improvise. Right, it's not going to be the same at all, is it? It's not going to be the same. What do I do? What do I do? Right, I'm not doing this again. Give me 10 seconds. Ooh. Oh, that's smelling. Another absurdity. I'm just going to plug this flashlight in for 2 seconds. So what we have, they say, if the sun was on and it turned off, again, I can't believe I'm saying this, and it turned off, it would take the darkness 8 minutes and 20 seconds to reach us, because it's this finite thing. It travels at speed. So if it turned off, the darkness would travel at speed. But that is honestly all horseradish, because if it turned off, there is no light without a source, so it would just disappear. So here we have it, right? It's a beautiful day on planet Earth. Right, see the shaded area here? Right? This is going to be the sun, and it turns off. So it's a darkness, see? It's a darkness, it comes like this and bush, see? Right. So, it's a beautiful sunny day. Wednesday afternoon, okay? Wednesday afternoon, sports afternoon. And everybody's happy on this side of the planet Earth, side facing the sun. It goes out suddenly. Nobody finds out for 8 minutes and 20 seconds. Nobody's going to know that the sun, which is only 108 diameters of itself away from us, nobody's going to know it's gone out for 8 minutes and 20 seconds, because it takes the sun 4.6 seconds to radiate each of its 108 diameters. Now, as the darkness, like 3 minutes has passed, 4 minutes has passed, 5 minutes has passed, 6 minutes have passed, 7 minutes have passed, 8 minutes have passed, still nobody knows, right? The darkness is upon them. The moon, in fact, we could pretend the moon is there. The darkness is in between the moon and Earth. So there's light one side and darkness the other. If you had one of those cameras and you were in a spaceship somewhere over here, one of those cameras that do the 10 trillion frames per second, you could make a fortune out of this one. Because you see electronic. And then that last 100 billionth of a second, because they break the seconds down, you know, to that 300 billionth of a second, no problem nowadays. And, or in 1971. And then, bang, plunged into darkness, apart from the North Pole up there, which is probably a good thing. So the planet is plunged into darkness and everybody screams, what's happening? Not everybody, because everybody on this side, it's dark anyway. They're still asleep, apart from the party animals. And then the message would go around, hey, so the sun's gone out in the other hemisphere. What? Right, but 8 minutes and 20 seconds it took. Now, if the sun switched back on again, this is your science people saying this, okay? So, the sun switches back on, suddenly, right? Now, there's the darkness, the sun has switched on, and this is the sunlight coming now, okay? So what is said is even the people that were facing the sun, if it turned back on, you wouldn't see it. You wouldn't see it. You wouldn't see it for 8 minutes and 20 seconds. You would not see the sun. You wouldn't even see this is where the is everywhere, okay? How would you not see the sun? It's only 108 diameters away from us, right? It's ridiculous. But they say you would not see it. It's coming as a, there's something a little bit special for this. Christian Huygens, right? The different points of a wavefront or wave crest of light set up an infinitely numerous series of secondary waves. These secondary waves reinforce each other after a time and produce a new wavefront. Other secondary waves arise and these result ultimately in still another wavefront. Thus light is propagated. And Galileo, you can't believe it. He said, Christian Huygens, this is fantastic. How did you... Right? And that was all done in 1600s. Come up with that in 1600s. So the light is approaching. Right? It's still dark, as you can see. Right? I moved it out late. It's still approaching. It's, let's just say it's 1 sun diameter away from planet Earth. It's been traveling for 8 minutes, 15 seconds or 15 point whatever seconds, right? We've got about 4 and a bit seconds to go. It's 1,300,000 kilometers away. The light, because it's coming. You heard Christian Huygens, propagated wave and another wave, and the other front creates another wave, plus then light is propagated, okay? And then, nobody, still here, nobody on planet Earth would see it. That's what the science says. Nobody on planet Earth would see it until... Somebody must have switched the sun back on 8 minutes and 20 seconds ago. Yay! That's your science. So that was just to show you where the sun would be after 8 minutes and 20 seconds. That's the way it is. If light takes that long and it hops and hips and crashes along at one of the sun's diameters every 4.6 seconds, that is what happens. So happy Science Day, peeps. 18 minutes. That wasn't bad. That'll do for now. What an absurdity. It's so obvious that it's absolute. It's so obvious it hurts. Anyway, later peeps.